All right, on page 108, it also mentions geometric properties. Okay, in other words, you can actually take an x-ray of a body part and it'll appear either blurry or it could appear larger or smaller than it actually is. Okay, if the patient is moving when you hit the button, the exposure button, you're going to have like a blurriness or a fuzziness on the x-ray. It's just like with old cameras. If you were trying to take a picture of something moving, then a lot of times it would come out blurry. So that's why you got to make sure the patient stays still. When you do a chest x-ray, they have to hold their breath because that little bit of movement in the chest can cause everything to come out blurry. Okay. Also, if you have the x-ray tube too close to the patient, what do you think that's going to do? Is it going to make the bones look larger or smaller? Larger. If the tube gets too close, it magnifies the bone. Okay? If you're doing a chest x-ray and the x-ray tube is too close to the chest, it can make the structures in the chest look larger. Like maybe the heart will look larger than it is. It's because it's like you're magnifying it. So you have to remember to make sure your distance is correct so that you don't change how big or how small it is. That's called the geometric properties. They actually call it the OFD, the object to film distance. That's on the bottom of page 5. The object to film distance is that small distance between the x-ray cassette and the body. Okay? That's why when someone does a chest x-ray, you have them stand right up against the bucky that's on the wall. Okay? If they're standing like 5 or 6 inches away from it, that means they're getting closer to the x-ray tube, so that's going to make everything look bigger. Okay, so you got to get it right against the x-ray cassette. Another thing, we've been doing some x-rays this week where you have to turn the x-ray tube. Okay, for example, the x-ray of the calcaneus, the dorsoplantar, how much do you angle the x-ray tube? 40 degrees. Okay. What about for the foot? 5 degrees. So if you angle it too much, that can also affect the way that the bone looks. That's another thing that affects the geometric property. So making sure you're using the right angle of the x-ray tube is important. All right, look on the top of page 6. It talks about the focal spot. Okay, on the top of page 6, it mentions the focal spot. The focal spot is this little spot right here where that beam of electrons come across and hit the anode. Okay, it can either be a small focal spot or a large focal spot. It depends on how much milliamps you use. All right, on your X-ray control panel, you have different choices for milliamps. When you look at the 50 or the 100, it has an S next to it. Okay, that S tells you that it's a small focal spot. The 150, the 200 have an L next to it. That means it's a large focal spot. All it's telling you is the size of this spot right here. Okay, small is usually like 1 millimeter. Large is 2 millimeters. Okay, so what you want to remember about this is you start to lose detail in your picture the more you have to turn up the milliamps. Okay, the lower the milliamps, the smaller the focal spot, you're going to get more precise detail in the X-ray that you're taking. Okay, so remember what small and large focal spots are. Okay, it also mentions this term called penumbra. It says it's the fuzziness at the edge of the radiograph due to motion. Right? In other words, if someone moves, like they move their foot when you're trying to take an X-ray of the ankle, and the bone looks kind of fuzzy or blurry, that's called penumbra. Make sure you remember that term. It also mentions it on page 109 in the book. and on 111, you see an example of a picture. They're showing angling the X-ray tube and how that can affect the way the picture turns out. All right, so at the end, the summary on page 111 kind of summarizes most of what we just went over. It tells you, what contributes to the density. It says a high MAS, a short TFD, a low grid ratio, all affect your density. Also, it says a small field size. What does that mean, small field size? That's your X-ray beam, the light. The smaller the light, the darker the picture is going to come out. So when you spread that light out, you're spreading out how dark or how light it's going to be. So a smaller field size is going to be a darker film. All right. In addition, you should place the anode side of the tube over the thinner body part. So that's the anode heel effect. All right. Now, there's some questions on the next few pages that are kind of confusing because you have to think about everything that we just went over in order to answer these. That's what I want you to look at right now. There's 20 questions starting on page 113. So see if you can answer those and then we'll go over them.